बहुत आवाज़ है पूजा. Hello. So everybody's in. All right. Shall we begin?
Yes, sir.
Yes, sir.
Okay. So, all right. So what we have discussed on the last session, that might be the movement of game object, I believe. Okay. So last time we have implemented learning towards like what are the techniques, how to manage those mono behavior, how to control your life cycle based on the scripts. Just a second, it's not responding. Okay, all right. So for the last lecture, we have learned this particular things, what can be done. Okay, so everyone must have uh, knowledge about how the execution order is. First is awake, on enable, late update, fixed update, all those kind of things. Okay, an update is called on every frame. Similarly, late update calls on every last of the frame, means after the frame has been finished. Okay, so it is almost same as late update, it will execute in the same way. Okay, so last time we had moved the entire object, correct? So now what we'll do is we'll control that particular object. So here's the script. So we can change the scale, we can change the rotation, and we can change the position. Okay, and while updating, it is commented out, but while updating, this is how we, you know, controlled our game objects for the moment. So let me just uncomment it. Okay, so if you want to just move the particular object in that particular speed, we can do that. Okay, so as you all know, every game object has its own transform component. Okay, that everything which you see which is attached on the game object which you see on the inspector, these are all the components, but these are ultimately the scripts which is predefined, or our own self-made scripts can also get attached, which also acts as a component. So which is why perhaps we know that this is why uh, the components works around. Okay, so whichever script has a mono behavior will get attached to game object, that can get attached to the game object. All right, so here this mono behavior script can access transform elements, and this script can also access another components as well. So so while so Unity predefinedly gives us the access to the transform component without asking for an access of it. Directly we get the access of it because this is this is what comes under mono behavior. Okay, so if you want to control the movement of the game object based on the values which we provide. So you might, from the last lecture which I already mentioned, like the position has three dimensions, also for the rotation and the scale. Okay, for the positions it is x, y and z. As we know, 3D it is x for the left and right, y is for up and down, and z is for depth. Okay, which is going forward and backward, and whichever things is getting rendered, okay, is done by camera itself. So camera also have its own transform, which will be the position, like whichever position we ask for it, like whichever position we set it on the scene. And as you see, the camera also has a component, the camera named component. Okay, so it has another component, audio listener. Okay, and another things which is not required for the moment, we can also turn it off. So so yeah, so these are the basic components. The audio listener listens to the audio, whichever audio is getting played, and camera that you know renders everything which it sees. Okay, which has its own frustum view, which you can see, this is the frustum view. So you can see the lines, like whichever things comes under it, it gets rendered. Currently it is in 3D plane, so it is called as perspective, which you can see the depth clearly, and which you can control it over here. So basically orthographic is similarly something else which renders in a very flat dimensions without rendering the depth specifically. So if you are making a 2D game, so you might prefer an orthographic view, because you don't need a depth, but you will need a layering components, which is sprite renderers, which will help us to render which things needs to come forward and which things needs to rendered backwards. Okay, so perspective is similarly like a visual camera, which you guys pretty much aware of, like how to record those things, how which you record it on your cell phone. So this is how exactly how it works. So it basically it captures everything what it sees, yeah, under its own frustum view. Okay, so yeah, so this is it. And last time we have also done adding another cube under the game object. So if the cube is inside it, okay, so whichever things which is the parent is moving, the child will also move itself. Okay, the child will also move itself. So last time when we have movement script here, and we can define the script scene, like where it will move, from left, right, up and down. You see it has pre-positioned itself because we have added few codes in the start method which calls only once. Okay, so this is not required as of now. So we have scaling the code, we have scaling that game object, we are rotating the game object, and we are also moving that particular game object. We are positioning it directly. Okay, and now there is a code which tells us that this cubes needs to be translated on every frame with the desired speed, but it is not moving currently because the cube the speed is 0. Once I increase the speed, you can see the cube is moving. Okay, why it is moving? Because I have placed the speed variable on y-axis. If you see, vector 3 has 3 parameters. Okay, one is x, another y, and the last one is z. So transform dot translate, this is a method. This method takes a vector 3 value. Okay, this vector 3 value. Okay, so it basically positions itself, position it means it help us to systematically move to a certain position and also updates its last position. So based on that, it keeps adding the position on every frame. So whichever values is we place it over here, it gets simply added to transform position. Okay, so right now, what if I want to move it with my WASD movements? WASD, the keyboard. Okay, the WASD or the mouse or the uh, arrow key movements. So simply we need to access a specific class which has been provided from Unity, which is input class. Okay, so in this input class, okay, we have a dedicated things inside the input class which you can see in the project settings. um, if you don't have this project settings, you can simply find it under edit and project settings here. So I have kept it docked over here beside the build settings because it is really helpful to make the builds and do a quick around settings. So in the player settings, there are few settings which is related to the project, and as you can see, there is an input manager. Okay, input manager. This input manager has a specific axis which is a very generic way, which is horizontal, vertical, fire, fire 2. So these are the actual names. These are the actual names. You can see these are the actual names. So what we are going to use is, we are going to use horizontal and vertical to control our cube. We are going to use horizontal and vertical to control our cube. Okay, so what does it define? You can see a positive button is up, which is up arrow key. The negative button is S, or you can say down negative button, negative arrow button. There's positive up. Alternatively, the alternate buttons, the similar way the alternate buttons is down button is S. Okay, and the positive button is W. Similarly same for horizontal as well. So it is left arrow button and right arrow button, and alternative of negative is A and positive is D. So it all mix up with WASD. Okay, so we are going to use horizontal and vertical for controlling those elements. Okay, so how are we gonna do it? We are just simply going to use the input class. Okay, so input class is something which we can get. So what we'll write, we need two floats. You can declare it on the public variable. So it is public float x and public float y. Alright, so what we are going to use is simply just rename this entire thing. I'll rename this entire thing into new vector 3. Okay, inside on x axis I'll place x, inside y axis I'll just simply put 0 for now. I want to move that cube in z axis. So what I'll do is I'll convert that y position of the controls to the z. So what I'll do is I'll simply ignore the y axis and place the y axis on the z axis. So what will happen if I click on W or maybe the up arrow key? So my inputs will directly go to z axis rather than y. So the vertical forms, vertical, which is W and S, or you can say up arrow key and down arrow key, is simply getting fed on the z axis of the position of the cube. Alright, so what will happen is currently these are 0 and 0, so nothing is going to happen. Okay, so this x and y I need to provide some values from input field. Okay, from input, so what I'll add is x is equal to input dot get axis. Okay, so what is written over here? Horizontal. You must write it in a very sophisticated way. So h is capital and other things are lowercase. So h is uppercase and other characters are in lowercase. So you make sure of that. If you write everything in lowercase, it won't work. So you need to write horizontal. Okay, so x will be for horizontal movements and y will be for vertical movements. Input dot get axis vertical, and you can see I have written in a literal format. Okay, a literal format. Okay, a string literal. Okay, this is a string literal, this is a string. This get axis is also a method. The input is a class and the class, it is a static class, and get axis is its static method, and it is accepting one parameter which is string. Okay, so what I am providing is the value which I want, the input value which I want. So what will happen is I am passing horizontal and it will give me a certain value. Similarly for vertical as well. Those values, as I have mentioned in the previous classes, the right hand side of the equal to is always moves to the left hand side of the equal to format. So RHS equal to LHS. So whichever value holds on the right side of the equal to gets added to left hand side. Okay, the values. Okay, so whichever values we get is stored in this variables. Whichever values is on right side gets stored in x. Okay, so this is a universal thing you must remember whenever you program. So yeah, so this is how we do it, and now we have those values. Okay, we have those values in x and y, and we are passing it into translate method. So it is vector 3 x is placed on the x axis, y is 0, so we don't need to change y, and we are placing y in z axis because we need to have a movement like third person, so it will move left and right. Okay, forward and backward, which will be on z axis. Okay, and I'm multiplying it with time dot delta time. As you know, the key thing for the time dot delta time is to make it universally, equivalent to all devices on every frame. Okay, like whichever frame rate it is, it will make it equivalent. It will be similar for the players who are playing on 30 fps, and the players who are playing on 120 fps or even greater. So it will be similar to all. Okay, so let's begin playing. And I've removed the start. Okay, that's fine. I'll just remove the start method. It is not required at the moment. Okay, so I'll predefine the speed, like I want to have a speed of maximum 5. Okay, so everything is going to multiply, but I guess the speed is not getting used over here. So what I'll do is I'll simply multiply it with speed. I want to have it multiplied with the speed in order to have more controls. Okay, so x is multiplied with the speed, also y is multiplied with the speed. Okay, and now if you watch here carefully, what is going to happen. If I click D, if I click D, okay, see it, when I click the D, it got 1. Okay, it got 1. Okay, if I click S, it is getting -1. So the cube is under my WASD controls. If I click W, or maybe the forward, the up arrow key, it will go forward. If I click S, it will come backward. If I click both, what will happen? It will move to forward right. Okay, like this and like this. So the cube is under my control now. Okay, any doubts here?
No, sir.
Okay, so these are the basic things that we are going to use. Similarly, you can also make it more simplified by just removing speed and also multiplying with the speed.
Sir, I have that doubt.
Yes,
सर हमें वो वैल्यू नॉर्मलाइज भी करनी पड़ेगी ना.
yes,
लाइक अगर मैं एक्स एक्सिस पे वन मतलब एक कोऑर्डिनेट आगे जा रहा हूँ, वाई पे एक जा रहा हूँ, तो दोनों का मतलब पाइथागोरस से करेंगे तो वो 1 और वो √2 होगा, तो वो ज़्यादा होगा ना, वहाँ पे स्पीड हो
Yes.
जाएगी, डायगोनल स्पीड बढ़ जाएगी और
yes,
वर्टिकली और हॉरिजॉन्टली कम होगी.
yes, correct. Because इसमें यही होता है that you need to also normalize this. Normalize as in इसको we have to make it a diagonal thing. So diagonal is greater on the square movements. So other than if you are looking on the rectangular or a squarish thing, the square edges and the diagonals are different. So diagonal is always greater, so the player will move more faster in diagonally. So we need to also normalize this. Okay, so what I'll do is I'll also add that particular thing into vector 3. Position is equal to new vector 3 time dot delta time. Okay, and what I'll do is position dot normalized, just normalized it. So this will be a unified movement to all the axes. Wait. It's almost the same. Maybe here. It's moving really fast. What am I missing here? Should be it, I believe. Point one. Hmm. Hmm. Everything is correct, yet it is moving really fast. What am I missing here? Position at the 3 time. Normalized is also correct. Oh wait, and I forgot, I need to add the speed as well. My mistake, I forgot to add the speed. Now the speed will be 1. Speed into time to delta time. X, Y, position, translate, position. Hmm. Maybe what I'll do is transform dot position plus position. That should make a difference because might be giving the static value for the translate, which is eventually getting added to it, and it's also the same. Point one, also the same. Mhm. So the same. What is the value I'm getting? Alright, okay. So ultimately I'm getting it a value which is already getting overridden by normalized. Alright, now it is working. So basically the normalized was getting overridden by the time dot delta time which was I was working before. So basically after normalizing it, then we need to multiply the time dot delta time, so then it will get normal. Okay, so this is how it is done. So this is the movement of the cube. Okay, and now, like, if I want to have a control with the mouse, okay, just with the mouse, okay, like it follows to my mouse position, so I can simply do it with the raycast thing. Okay, with the raycasting thing, so what can it be done is, through the camera I'll point to the specific position and will provide that position. Okay, so what can it be done? So instead of controlling, we just provided the positions. Okay, and before that I'll just quickly give you one thing, a quick exercise that you need to also do it at the homework. Okay, so here I'm placing a plane here, a simple plane, and I'll just reset its positions. Okay, so this is our cube, and inside that plane I need to have a basic positions, empty positions. Okay, you can use this to control your game view, if you can see correctly. So these are the views. Okay, if I click over here, it will get orthographic, and this will be perspective, but this will be orthographic only for the view purpose. It won't affect the camera, but yes, what I'll do is I'll place 3 points. Let's say this point, this point, this point, this point, and this point. So I have placed 4 points, okay, on the edges of the cube. You can do it yourself as well, inside the plane. Okay, so if I move the plane, the points will also move along with the plane. This is why I've placed it to the child of the plane. Okay, so what I really want is the cube should follow these particular points in a desired manner, or maybe in an equal intervals. Okay, equal intervals. So any of you knows how it can be done in that equal intervals? So here we are going to use
सर फिर
Yes.
से फिर से बताए प्रॉब्लम स्टेटमेंट क्या है?
The problem statement is there is a plane and it has 4 empty game objects. Okay, I want that cube to be following each point in a proper interval. So let's say in 1 second it will travel here, another second it will travel here, another second it will travel here, and again it goes back to here, and it keeps doing forever. It keeps
सर लूप लगा देंगे, पहले वहाँ पे, फिर यहाँ पे, फिर वहाँ पे, फिर वहाँ पे, फिर वो चलता जाएगा
yes,
जब तक हम हमारा गेम ऑब्जेक्ट वहाँ पे एक्सिस्ट करना बंद नहीं करता तब तक.
correct. So loop, we will be using loop, but how we'll be defining those positions?
सर ये सब एक ही सीन में है, यानी सारे के सारे ऑब्जेक्ट है वो हमारे जो सैंपल सीन है उसमें ही है. तो हम क्यूब किस है उसको उससे मतलब करने वो कर सकते हैं. और उसको मुझे जावा आती है तो जावा से बताता हूँ कि जैसे हम क्लास को एक्सटेंड करते हैं वैसे ही हम प्लेन को एक्सटेंड करेंगे. वहाँ से गेम ऑब्जेक्ट का जो पोजीशन है वो लेंगे, फिर गेम ऑब्जेक्ट 1 का पोजीशन लेंगे, 2 का लेंगे और 3 का लेंगे, और उन पे लूप चलाते रहेंगे.
Okay, and how will you check that if cube reach to that particular position? Like let's say, how will you check if the cube has been reached that particular position, then it needs to be traversed to another location?
इफ एल्स लगा देंगे कि क्यूब का पोजीशन इज इक्वल टू गेम ऑब्जेक्ट पोजीशन. वो चेक कर लेगा, अगर वो वहाँ पे है तो वो नेक्स्ट पे चला जाएगा कि हाँ अब मुझे नेक्स्ट पे जाना है, तो वो वहाँ पे नेक्स्ट पे चेक करेगा, वहाँ पे पहुँच जाएगा तो वो वापस से नेक्स्ट पे चला जाएगा. वो हम फिक्स अपडेट में डाल देंगे. अगर ये हो जाता है तो वो अपना टारगेट चेंज कर लेगा.
Correct. So this was the right answer. So how we'll be doing it, that we need to define those 4 game objects, these empty game objects. We will be leveraging these game objects to move our cube from this particular points, all right. So how will we doing it? We need to give a reference for this. We need to have a reference, and at the very first lecture I have already mentioned like how to declare the variables, but after that how we'll be using those variables in a list or an array. So array is a collection of similar game objects, okay, or similar objects, or the similar data types, as you can get to know what it is. So how to declare an array? Just simply type a variable type. So let's say if I want to have it a public, which is the access modifier. So access modifier, then it will be type. So type will be, for our case, it can be game object or maybe this component. this component. But you will ask that we already have a transform component with the game object, but the game object, the transform component which we already have, is for this game object only. So whichever script it has, it can only get the transform directly on that particular game object which has been attached to. So this movement script has been attached to cube game object here, so it can only access this transform. But I want to access these 4 transforms at the same time. I want to access this 4 transform at the same time. Okay, so what I'll do is I'll simply write the class name. Okay, the class name. So it is what it is. This is transform. This is also transform. This component is transform. So what I'll simply write is transform. Okay. Now, in order to make it an array, I'll simply hit with 2 square brackets, and I'll just name the variable name. So for us it will be positions. Okay, so us it will be positions. Okay, so this will be our positions. Okay, this 4 will be our position. Okay, so now when I added this, okay, positions, now you can see there is a small array beside the position. So this simply declares it is an array or it is a list. I'll come to the list on the later part of the lectures, but for now you can get started with the arrays. So arrays is simply a collection of a similar data type objects. Okay, so it can have n number of elements inside it. Okay, so now what we'll do, this cube which has the script, okay, this cube which has the script has positions. Now it is asking for positions, so I'll simply click plus over here and add the first game object. Then again I'll click first. You can see there is a similar game object and it is the same game object, but we don't want that. We want another game object. Then again third game object and fourth game object. Okay, so now we have taken the reference of this all 4 game objects. Okay, all 4 game objects as an array. Okay, in order to control those array elements, okay, we need to have an index. Okay, so maybe you can call it an address for it, to a postman, how it can find your house by your address. So basically each element has its own address. Okay, which in our programming case, which we can define it as an index. So index of a position. So if you see this position, so first game object has an index of 0, second is 1. So every array begins with 0. Okay, the first element of an array, whichever it is, whether it is an integer, whether it is a game object, okay, whichever it is, the array, the particular, sorry, hello,
सॉरी सर, वो गलती से चालू हो गया था भाई.
okay. So for this particular thing, whichever it is, the elements, whichever type of array it is, the first element always begins with 0. Okay, which is also universal. Okay, the first element, second element and the third element. So first element of that position array is this. So now we'll be using the first position. For that first position, which we'll be using to move that cube. Okay, so what I'll do is, first I'll just simply show how we can directly move to the first element of the array. Okay, so I'll also add public integer index. So this index will be used to access the values inside array. Okay, so what I need is I want to move that particular object, this particular the cube, into the uh, first element of the array of transform. So transform dot position again, so it will be, you have to access the transform, you can access from transform, you can access the positions and rotations and the scale from the previous lecture which I already mentioned. This is rotate and this is scale. So for now, in our case, the position is it. So now we need to update the positions. So what we can do is we can simply add positions, which is a transform element. Okay, which is a transform element. So transform, which is our array, so we need to access again with the square brackets. Okay, and we need to pass index, or you can simply pass 0. Okay, so what will happen, this will return the first element of the position, so which in our case it will return this. Okay, the position of this. So currently if I just simply write positions dot 0, okay, it will give an error. Why? Because the position takes vector 3 and it is returning us transform. Okay, it is returning us a transform. Okay, it is returning us a transform, so we don't need that. We need to have vector 3 of that particular transform, so position of the transform, so which is also vector 3. So we'll write position of it. Okay, what if I write local scale? It will still accept it. Okay, so while compiling it has no errors, but logically it has errors. It is illogical correctly for what task we want to achieve it currently. So what we will do is we just need the position, of first element of the transform. Okay, first element, so which is this. Okay, we already have the references of this 4 elements, 4 game objects. Okay, as in transform. Okay, so what we'll get is this game object will get this value 4.480 and negative 4.54. so we'll get this value, and this value will be fed to this, and this cube will move to this position here. Okay, so if I click play, you can see the cube has been moved from here to here. Okay, so what if I make it 1? Okay, what if I make it 1? So 1 is here, so the cube will jump to here, means it will teleport to here, to this position. Okay, and what if I place 5 over here? What if I place 5 over here? The cube,
error I.
yes,
In
so it will give an error. Why? Because at the run time you are asking for a address of the element which does not exist. Okay, which does not exist. So currently we have 0, 1, 2, 3. It's total of 4. Okay, and we are accessing 5th. Okay, we are directly accessing the 5th, which is not possible, so it will give an error. Okay, the cube won't move, and simply we will get an error over here. And what the error says, index was outside the bounds of an array. Okay, so it is outside the bounds of an array because array doesn't have it. Okay, So now, as you know, now we'll just simply pass index for now. Okay. So now whatever index it is here, it will simply move to that position. The reason I make it public, because in order that you can see how to access the array and how you can leverage those array elements to control the queue. So it should be easier for you to work with the arrays. Many students which I have seen, they get scared with arrays, but it should not be the case, because it is really easy if you practice with it. Yes, on each things now you can move it to certain positions. Okay, and now what if I want to make it real time? So I'll just simply place it over here. Okay, so whichever position I give, okay, so it will move to that particular position. So currently it is 3. If I place it 2, if I do it 1, if I do it 0, why it's happening? Because I have placed the code in update method. So each frame it is checking if the index has been changed. Okay, so whichever index I provide, it will simply move to that particular position. So now if I want to directly move from position A to B, then B to C, then C to D, then D to A, so how will I do it? I'll simply write a code that will move the queue in the respective place. Okay, in the respective place. So with the use of index, okay, with the usage of index, I'll simply write so I want it to have uh, you know a specific way. Okay, in a specific way, like for now, not in a smooth form, but directly just teleporting from point A to point B, point B to C, directly teleporting. It is very easy. Okay, just you need to have a delay, but in order to have a particular moment in a smoother way, like it is moving from point A to point B gradually, okay, that will be doing on the next lecture. But for now, I'll just make it on the delayed form. Okay, so this start method, currently it was void. Okay, currently it was void, but for that I can also rename as returning method as IEnumerator. Okay, IEnumerator. So you must name it correctly, which comes under collections. Okay, so this, if you get error, just simply check if you have this. If not, you can write this system.collection, which comes under this. So IEnumerator helps us to make a delayed a delayed response for the code which we write. Okay, so what we can do is, I'll simply write a code. Okay, simply write a code for loop. I is equal to 0, I less than positions dot length, and I plus plus. Okay, so what will happen now? It will iterate through all the numbers from for loop, whichever it is. So currently the start is maybe like everyone might be knowing what is the for loop is. Everyone might be aware with that. Okay, if not, I'll just explain, like this is the start, this is the end, and this is the direction of the loop. So it is forward or negative, whichever it is, or maybe the iterator of it. You can just simply say the iterator. Okay, so currently I plus plus defines that it will iterate plus one value of each iteration. So let's say if one loop is processed, it will iterate plus one of the particular value of I. So let's say currently the I is 0. So once the loop is over, okay, so it will check again and it will iterate I with 1. Okay, so let's say if I was 0, then it will change it to 1. If it was 1, then 2, then 2 to 3. And this is the limiter, that how much it should iterate, how long it should iterate. Okay, so currently the length is 4, the positions dot length which we get. Okay, this is our length, or maybe we can just hard code it here, 4. Okay, so it will go from 0, 1, 2 and 3. It won't go till 4. Because why? Because I is less than 4, so 3 is less than 4, correct, but 4 is not less than 4. 4 is not less than 4. Okay, so in array when we begin, the length is 4. Why? It has 4 elements, but it also begins with 0. So you must consider that the 0th is the first element, the first is the second element, the second is the third element. Okay, and the third is the fourth element. Okay, so just make sure you have a -1 while considering the iterations of the array. Okay, so for this for loop, now what we'll be doing it, that we need to move on every in every possible iterations of that loop, and we will be waiting for 1 second on each iteration. Okay, in order to wait, what we'll simply write is yield return. Now it is asking for what? A frame, a second, or ticks. So we need seconds. So what I'll write is new wait for seconds. Okay, wait for seconds. How much I should wait? 1 second. Okay, on every second. Okay, I'll change the position. Okay, I'll change the position here. Transform dot position. Okay, is equal to positions of I, not index. I, because we are getting I, not index. Now again it is giving an error because positions dot I will give transform, not the position. But from that transform we need to have a position, so we just write position. Okay, so what will happen with this code? It will simply move from one point to another point in every second, but it will stop. It will stop. Okay, so where I start, one, two, three, 4. Okay, once it has been completed, it stopped moving. And what I'll do is, if I equal to 3, I'll simply make I is equal to 0. Okay, so why equal to 3? Because 3 is the fourth element. So if 3 is the fourth element, so it will make it to 0. Okay, so again it is 0, which is again I is less than 4 and I plus plus again. So it will keep looping. 0, 1, 2, 3, 2, 3, 2. So now it is moving 2, 3, 2, 3, 2, 3. Okay, so what I'll do is, I'll simply, because I am keeping it as 0. Why it is 0? So when it is 0, when from here it is going back here, so it is considering again 0, so it is incrementing that. Okay, so it is considering it as, now it is already incrementing 0 as 1. What I'll do is simply write -1. So what will happen when the loop is over? when the particular piece of block of code is over. So it will give 0, which will increment it anyways. So from -1 it will get 0. Now on every 1 second it is moving to the desired position. Okay, but on the next lecture what we are going to do is we will be manually checking the cube's position to the edge, whichever position we have, and we'll be simply moving that cube gradually to that position rather than just directly teleporting from point A to point B. Okay, any doubts here?
सर
Yes.
हमें ये जो प्रोजेक्ट है आप बना बना रहे हैं इसकी गिट रिपो की लिंक मिल सकती है या तो आप बना सकते हैं तो
हाँ,
हमें
मैं-
रेफरेंस के लिए जाएगा पढ़ने के लिए
हाँ हाँ मैं बना दूंगा. I'll create one git repo for you. Also I've recorded the lectures as well for this, and I'll upload it to LMS. I didn't got the access to LMS yet, but I'll add that to LMS as well. Okay, I'll give you the access to the videos and the git repo on the WhatsApp,